Hey everyone, it's time for physics. Today, could you survive a whale lord body slam? Wailord is the largest known Pokemon, coming in at 14.5 meters. That's just shy of 50 feet. And today we're going to see if you, or this guy sitting in a bathtub, could survive the incoming Wailord body slam. Well, it turns out that if you were this guy sitting in this bathtub, you wouldn't worry at all, because you are Archimedes, and you know all about the buoyant force. The story goes that Archimedes was tasked to build a large ship, and he was pondering how he could get this massive thing to float, as it had to carry lots of supplies and animals and people all around. And as he lowered himself into his bathtub after a long day of thinking one night, the water splashed out and over the sides of the tub, and suddenly it hit him. The water that spilled over the sides is the same volume that my body displaced. And after some working out, he realized that the weight of that water was equal to how much lighter he got in that water, or this thing called the buoyant force. We have come to know this as Archimedes' Principle. More simply put, this just says that the weight of the fluid displaced is equal to the buoyant force. So a cube in water will displace a cube of water, and that cube of water has some sort of weight. And that weight is the same thing as the buoyant force that the actual cube would feel. So we start with the buoyant force is equal to the mass of the fluid times gravity. But it's kind of hard to mass fluid, so what we're going to do is bring in our density equation. Density, or rho, is mass divided by volume. And then if we just solve this for mass, we get mass is rho times volume. And then we're going to just plug it in there. And we get that the buoyant force is equal to the density of the fluid times the volume of the fluid displaced. In this case, it was the entire cube, times our old friend, the gravity constant. Now, balloons float because of this thing called the buoyant force. They are displacing enough fluid, in this case air, such that the weight of that air displaced is much, much greater than the weight of the balloon. And therefore the balloon will float up off into oblivion. But enough about that, let's go back to Wailord, the largest Pokemon. If the thing that we're looking at is submerged completely in the fluid, we can just use the volume of that thing. Now, I've done some calculations, and I've estimated Wailord to be a cylinder with a half sphere on either end. So running the numbers of our 14.5 meter Wailord, we get a total volume of 322.56 meters cubed. Now we know that the density of air, because that's what Wailord will be in when he's performing the body slam, and this is going to be at 10 degrees Celsius, or about 50 degrees Fahrenheit. The density of air there is 1.2466 kilograms per meter cubed. And of course we know that G is 9.81 meters per second squared. So what we need to do is calculate the buoyant force, and that's going to equal our density, 1.2466 kilograms meter cubed, times our total volume, which was 322.56 meters cubed, times gravity, 9.81 meters per second squared. And we get that Wailord has a buoyant force, or a force pushing up, of 3,940.6 newtons. So if we draw a free body diagram for Wailord, we have that there's a force pushing up of 3,940.6 newtons. Well, what is the weight of Wailord that's pushing down? Well, the weight of Wailord is just going to be mg, and if we plug 398 times 9.8, we are going to get a weight of 3,900.4 newtons. So down here, so the buoyant force is up, the weight of Wailord is pointing down, and that's 3,900.4 newtons. If we resolve this into just the net force, we have a net force up of about 40 newtons. So that means that Wailord goes up for a body slam, and, well, in this case, he's just sort of gonna float away. And actually, he's gonna accelerate at a rate of about 0.1 meters per second squared, or about 10 centimeters per second squared. Maybe that's why Wailord is called the float Pokemon.